So, in today's lesson, we'll begin thermophysics. We begin by explaining the kinetic theory. So, the kinetic theory of matter states that matter is made up of small particles that are in random, continuous motion. Keywords: small particles, random, continuous, and motion. These small particles can be ions, they can be molecules, or they can be atoms. The three basic components of matter, the three basic particles that make up matter. Ions, for instance, in sodium chloride, molecules, for instance, in carbon dioxide, atoms, for instance, in argon or helium. Now, we're saying these small particles are always in random, continuous motion. What do we mean by that? Well, let's take an example. Consider this is our particle. According to the kinetic theory, this particle is never at rest as it is right now. Instead, it's always moving. It's always in random, continuous motion. When I say continuous, we mean it's always moving. Random, meaning you have no idea where it's going to go. So, let's make this particle move randomly and continuously. It's going to move something like this. At any point in time, you have no idea where it's going to go. It can go up there, oops, he's went down. It can go up, down, left, right, center, up, down, left, right, center, left, 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 right, 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 up, down. You have absolutely no idea where it's going to go. And it's always moving. It never stops. It never comes to rest. This is the kinetic theory. Particles are always moving, and they move randomly. There's absolutely no pattern whatsoever. That is our kinetic theory. And it's going to be really important in understanding everything else that comes in physics from this moment on. So, hopefully, you understood that. Now, move on to our next objective, which is describing the molecular structure of solids, liquids, and gases. So, we know matter exists in three states: the solid state, the liquid state, and the gaseous states. So, in the solid state, matter has a fixed volume. It also has a fixed shape. The particles are tightly packed, like so. These are supposed to be perfect circles, but well, they're close enough. Bear with me. So, they are closely packed. Particles are closely packed. Yeah, they shouldn't intersect like that, but you get the idea. Particles are closely packed. And usually they form a regular pattern. Yep, I guess this is close enough to a regular pattern. Bear with me. Yeah, particles are closely packed, something like this. And liquids have a fixed volume, but not a fixed shape. They would take on the shape of their container. So if a container is like this, they would take on that shape. This is the liquid. If you put it in say, a bottle of Coca-Cola, okay, any bottle, say a bottle that looks like this, the liquid would take on that exact shape. So liquids do not have a fixed shape, but they do have a fixed volume. So when you look at the arrangement of particles in a liquid, it's kind of like this. Say our liquids occupy this volume. They're going to be spaced a bit, but still they will be confined to their group of particles. Something like this. This is the arrangement of particles in a liquid. Confined volume, but no definite shape. Gas. A gas has absolutely no shape and absolutely no volume. It can spread out to occupy as much volume as it needs to. Gaseous molecules, matter in its gaseous state is like this. Let me just add another particle, say somewhere here. So these are the three states of matter. And from our solid state, we can see that the intermolecular forces are very small. Very small. Intermolecular spaces. Did I say forces? I mean spaces. Very small intermolecular spaces. When I say intermolecular spaces, I mean the spaces between the particles. Here the particles are very close, like too close. That's what I mean by the intermolecular spaces. There's such little space between the particles. When it comes to our liquid, you can clearly see that they have larger intermolecular spaces compared to solids. Coming to our gases, they have very large intermolecular spaces. Gases have so much breathing space, so much space between their particles. Then you need to understand that these molecules have attractive forces between them. They're attracted to each other. And the attraction between this particle and that particle, the attraction between the particles that make up matter, is called intermolecular forces. So in solids have strong intermolecular forces. When it comes to liquids have weaker intermolecular forces when compared to solids. Weaker intermolecular forces compared to solids, but strong enough to hold the molecules in group. Coming to our gases, the intermolecular forces are almost non-existent. Almost in quotes and yeah, almost in quotes to give my idea. They are there, but they're too weak. So in gases, weak intermolecular forces. What I said about their volumes and their their shapes. Solids have fixed volume, fixed shape, then coming to our liquids, they have fixed volume, but not a fixed shape. They take on the shape of the container. So their shape is variable, it's not fixed. Coming to our gases, they have absolutely no fixed volume, and neither do they have fixed shape. No fixed volume, and absolutely no fixed shape. That is our gases. Yeah, and that's as much as you need to know about these. Can also talk about their compressibility. Gases are very compressible. Liquids are slightly compressible, but some will argue that they're not compressible, where it depends on what kind of liquid you're dealing with. But it's okay to say that they're slightly compressible. Solids are incompressible, generally speaking. And we have successfully described the molecular structure of solids, liquids, and gases. We learned something new in the first step of discovering thermal physics.